Roughly 40,000 years from now, long after every trace of human civilization as it currently exists has changed beyond recognition, a small, silent machine built in the 1970s is going to quietly slip past another star. Not our sun. A completely different star, more than 9 light years away from where that machine currently sits, and it's going to pass close enough, in cosmic terms, that scientists have actually been able to calculate the encounter down to a specific distance. And here's the part almost nobody realizes. Voyager 1 isn't the only spacecraft humanity has ever launched that's heading toward a future encounter like this. There are 4 of them, all currently drifting through the emptiness beyond our solar system, each one eventually bound for its own calculated, almost unbelievable rendezvous with the depths of interstellar space. This is a real, scientifically calculated story, based on actual trajectory data published by NASA and the Jet Propulsion Laboratory, and it's one of the strangest, most genuinely humbling pieces of long-term math our species has ever worked out. Every figure in this video comes directly from that published trajectory data. Not speculation, not exaggeration, just the genuinely staggering scale of what these 5 machines are actually still doing out there. Let's start with Voyager 1 itself, since it's both the most famous of these spacecraft and the one whose future path has been studied in the most detail. Voyager 1 launched on September 5th, 1977, and after completing its historic flybys of Jupiter and Saturn, it used Saturn's gravity for one final trajectory adjustment back in November of 1980. And it has been coasting in an essentially unchanging straight line ever since, moving at roughly 38,000 miles an hour. It has no fuel remaining for any further major course corrections. No way to steer, no way to slow down or speed up in any meaningful sense. Whatever direction it happened to be pointed in after that final gravitational assist from Saturn is, for all practical purposes, the direction it will continue traveling for the rest of its existence. According to trajectory calculations published by NASA, Voyager 1 is currently heading in the general direction of the constellation Ophiuchus, and its path will eventually carry it roughly 1.6 light years of a star called Gliese 445, a small red dwarf star currently sitting in the constellation Camelopardalis. That encounter is projected to happen in approximately 40,000 years. To put that distance in perspective, 1.6 light years is still an enormous span of space, roughly 9,400 billion miles, meaning this will be nothing like a dramatic, close flyby the way Voyager 1 once swept past Jupiter or Saturn. It will be closer to 2 ships passing within sight of each other across a vast, otherwise empty ocean, near enough to technically count as an encounter, but nowhere close enough for anything resembling actual contact or capture by that star's gravity. Here's what makes even that distant a pass genuinely remarkable when you actually sit with the numbers. Interstellar space is staggeringly empty. If you shrank our entire solar system down to the size of a coin, the nearest other star to our own sun would still sit miles away on that same scale, and the overwhelming majority of the space in between contains essentially nothing at all. The distance between individual stars in our region of the galaxy is so vast that the idea of any single object, moving essentially in a straight line, ever coming within a couple of light years of another star's location is itself a fairly rare occurrence over any given stretch of time. Scientists didn't calculate this encounter because Voyager 1 was ever deliberately aimed at Gliese 445. Nobody in 1980 was plotting a 40,000-year course toward a specific star. It's simply the trajectory that fell out naturally from the spacecraft's final gravity assist at Saturn, extended forward across an almost incomprehensible span of time, using nothing more than basic orbital mechanics and the patient, careful math of celestial dynamics, the same fundamental physics that lets astronomers predict where planets will be centuries in advance, simply applied here across a vastly longer timescale. Now here's the detail that I think deserves far more attention than it usually gets, because Voyager 1 genuinely is not alone in this. There are 4 other human-made spacecraft currently on similarly permanent one-way trajectories out of our solar system, and every single one of them has its own calculated, if considerably more uncertain, future encounter somewhere out in the depths of the galaxy. Pioneer 10, launched back in 1972, holds the distinction of being the very first spacecraft humanity ever sent, on a trajectory that would eventually carry it entirely out of the solar system. NASA lost contact with Pioneer 10 in January of 2003, its signal finally growing too faint to detect after more than 3 decades of operation, but the spacecraft itself continues drifting silently onward, heading in the general direction of the star Aldebaran in the constellation Taurus. Current estimates suggest that if Pioneer 10 continues on its present course, it could take somewhere in the neighborhood of 2 million years to actually reach the vicinity of that star, an almost incomprehensible stretch of time compared to even Voyager 1's own 40,000-year projection. Pioneer 11, Pioneer 10's twin, launched in 1973, and after completing its own historic flybys of Jupiter and Saturn, It too is now heading out of the solar system entirely, its own contact with Earth lost back in 1995. Pioneer 11's trajectory carries it in the general direction of the constellation Aquila, though because contact was lost decades before Voyager's more precise ongoing tracking became possible, scientists have somewhat less refined data available for calculating exactly which star it might eventually pass closest to, or precisely when. Voyager 2, Voyager 1's twin, launched just 16 days earlier in 1977, but took a longer, more roundabout path through the solar system, flying past Jupiter, Saturn, Uranus, and Neptune before finally heading outward. Its own eventual trajectory carries it in the general direction of the constellation Pavo, and current projections suggest that in roughly 40,000 years, on a timescale remarkably similar to its twin, it will pass within a few light years of a star known as Ross 248, itself a small red dwarf star currently located in the constellation Andromeda, before that star's own proper motion eventually carries it out of Voyager 2's path entirely, at which point the spacecraft is projected to continue on, potentially making a somewhat closer future approach to the star system containing Sirius many thousands of years after that. And finally, there's New Horizons, the newest of these 5 spacecraft, launched in 2006 specifically to study Pluto and the distant icy Kuiper belt beyond it. After completing that historic flyby of Pluto in 2015, and a subsequent equally historic encounter with the distant Kuiper belt object nicknamed Arrokoth in 2019, New Horizons is now also on a trajectory that will eventually carry it out of the solar system entirely, joining the other 4 spacecraft on a permanent one-way journey into the depths of the galaxy, its own long-term stellar encounters still being calculated and refined by mission scientists as its trajectory data continues to be tracked. What ties all 5 of these missions together is something genuinely worth sitting with. None of them were built with any expectation of ever being retrieved or repaired or even reliably tracked across the kind of timescales their eventual stellar encounters actually represent. They were built to study planets, moons, and the outer reaches of our own solar system, and every single one of these far future encounters is simply an accidental byproduct of the specific trajectory each spacecraft happened to end up on after completing its actual scientific mission. Nobody at NASA in the 1970s sat down and specifically engineered Voyager 1's course to eventually approach Gliese 445. It's an emergent consequence of basic physics, calculated only much later, once scientists had enough precise, ongoing tracking data to actually project each spacecraft's path forward across tens of thousands, or in Pioneer 10's case, millions of years. There's also a genuinely important detail worth being honest about, because it's easy to let numbers like these create a misleading picture. None of these 5 spacecraft are going to survive in any functioning sense long enough to actually experience these encounters as active communicating missions. Voyager 1 and Voyager 2 are both expected to lose all remaining power sometime in the 2030s, falling permanently silent decades, or in some cases centuries, before they ever reach the specific distances where these calculated stellar approaches actually occur. What continues afterward isn't a working spacecraft in any meaningful sense. It's simply an inert, silent object still following the same physical trajectory, still technically completing the journey scientists calculated, but with nobody left listening and nothing left transmitting. So here's what I actually want you to take away from all of this. Voyager 1's eventual, genuinely calculated encounter with Gliese 445 in roughly 40,000 years isn't science fiction, and it isn't exaggeration. It's real trajectory math, based on real ongoing tracking data, projected forward across a span of time longer than the entire recorded history of human civilization. And it's sharing that fate with 4 other spacecraft, Pioneer 10, Pioneer 11, Voyager 2, and New Horizons, each one drifting toward its own distant, silent rendezvous with a star nobody alive today will ever see it reach. It's worth remembering, too, that both Voyager spacecraft carry something the 2 Pioneer probes and New Horizons don't, a physical message deliberately included for whoever or whatever might eventually find them. Bolted to each Voyager's frame is the Golden Record, a gold-plated copper disc containing greetings in 55 languages, the sounds of Earth, and 90 minutes of music from cultures spanning the entire history of human civilization, along with diagrams intended to explain who sent it and where they came from. Carl Sagan, who helped lead the committee that assembled the record, once described it as a message in a bottle cast into the cosmic ocean, and given everything covered in this video, that description turns out to be almost literally accurate. Sagan estimated the record could remain playable for over 1 billion years, meaning it will likely still exist, drifting quietly through the galaxy, long after Voyager 1 has already made its calculated pass by Gliese 445, and long after every other trace of human civilization has vanished entirely. 5 machines, launched within a span of roughly 34 years, each one now carrying humanity's fingerprints quietly out into the galaxy, on journeys that will continue for longer than our species has even existed. That's not a comfortable thought to sit with for very long, but it's an honest, mathematically grounded one, calculated by real scientists using real tracking data rather than any kind of speculation or exaggeration. If you want to know exactly how scientists calculate trajectories across timescales, this vast subscribe and turn on notifications, because the actual orbital mechanics behind these projections are genuinely fascinating in their own right. And drop a comment telling me which of these 5 spacecraft you think deserves more recognition for the sheer scale of the journey it's quietly still on. Because honestly, after working through these numbers, I don't think any of them get nearly enough credit for what they're actually still doing out there.